This video is on solving absolute value equations. An absolute value equation is an equation that contains an absolute value expression. Recall that because absolute value represents distance, which is always positive, the algebraic expression between the absolute value bars can be either positive or negative. So for example, in the equation, the absolute value of x plus 4 equals 13, the expression between the bars, x plus 4, can be equal to either a positive 13 or it can be equal to a negative 13, because the absolute value of 13 equals 13 and the absolute value of negative 13 also equals 13. So to solve an absolute value equation, we first want to isolate the absolute value expression. So if there's anything being multiplied by the absolute value or added or subtracted to the absolute value, we want to get rid of that. We want to have absolute value of something equals just a number. Then we write two equations. The absolute value bars go away, and we take the expression that was between the bars and set that equal to both the positive value of the number on the right of the equal sign and the negative value of the number on the right of the equal sign. Then we have two equations and we just solve those separately. So let's take a look at several examples here. So it says solve each absolute value equation. Here we have the absolute value of x minus 4 is equal to 8. So my absolute value bars in this case are isolated. There's nothing being multiplied by the absolute value expression. There's nothing being added or subtracted to it. So at this point, remember this stuff here, the 2x minus 4, that's what's between the bars. That can either be an 8 or it can be a negative 8, because the absolute value of 8 is going to give me 8. The absolute value of negative 8 is also going to give me a positive 8. So from here I'm going to write two equations. The stuff between the bars, 2x minus 4 is equal to positive 8, and 2x minus 4 is equal to a negative 8. So now I'm going to solve each equation by adding 4 to each side. And then divide by 2. So x is equal to 6. And doing the same thing with this equation, adding 4 to both sides. Negative 8 plus 4 is negative 4. And then dividing by 2 gives me x is equal to negative 2. Notice that for most absolute value equations, you're going to have two solutions because you've written two equations. Okay? The key thing is to take the expression between the bars, make it equal to a positive number, and then make it equal to the same number negative. Let's take a look at our second example here. The absolute value of x minus 3 equals negative 7. Well, let's think about this one for a minute. Instead of writing two equations, I've already got a negative number over here. What does that mean? That means that I'm going to plug in a number for x, subtract 3 from it, take the absolute value of that number, and then get a negative 7. Well, that's not possible. It's not possible to take the absolute value of something and get a negative number, because remember, absolute value represents distance. Distance is always positive. You can think of it as the bars make it positive. So this one actually has no solution. There is no number that I can plug in for x, subtract 3, take the absolute value, and get a negative 7, because an absolute value cannot yield a negative number. Okay. Let's take a look at our next example here. I have negative 2 times the absolute value of x plus 5 plus 3 equals negative 11. Now, before you all of a sudden say there's no solution because it equals a negative 11, realize that I have not isolated my absolute value yet. I have to get rid of all of this stuff that's around the absolute value bars. I have to get rid of this times negative 2, and I have to get rid of this plus 3. So the first thing I'd like to do is subtract 3 on both sides. That's going to give me a 0, so I have negative 2 times the absolute value of x plus 5 equals negative 14. Now, do not distribute. Absolute value bars are not parentheses. We don't want to use the distributive property. What I want to do is divide both sides of this equation by a negative 2, because this is negative 2 times the absolute value of x plus 5. So those will create a 1. So that's going to give me the absolute value of x plus 5 is equal to a positive 7. Negative 14 divided by negative 2 is a positive 7. So from there I'm going to write my two equations, because the expression between the bars can equal a positive 7, or the expression between the bars can equal a negative 7. And solving this, I have x equals 2, and solving this one, I have x equals negative 12. So my two solutions are x equals 2 and x equals negative 12. Make sure that you're isolating the absolute value before you write the two equations. And my last example here is the absolute value of 3x minus 5 equals 0. Well, this one's a little strange too, because there is no such thing as a positive 0 and a negative 0. So this one is just going to have one solution. So the only equation I can write is 3x minus 5 is equal to 0. Adding 5 to both sides, 3x equals 5, and dividing both sides by 3 gives me x equals 5/3. So if an absolute value expression is equal to 0, there's only going to be one solution. So in this video we took a look at how to solve an absolute value equation. That we have to, first of all, isolate the absolute value. If there's anything being multiplied by the expression between the bars, anything added or subtracted, we need to get rid of that. And then we're going to write two equations. The expression between the bars is equal to a positive number on the right side of the equal sign, and it's equal to a negative value of the number on the right side of the equal sign. Most of the time you'll have two solutions. If it equals 0, you'll have one solution. If the absolute value of something equals a negative number, you'll have no solution.